Spec-Driven Development, or SDD for short. Now, this might sound fancy, but this has been going on in software engineering history for ages. So, what does this mean is that you have a set of, pardon my editing. So, you have a set of requirements, and then you create usually a detailed file or document which has all the instructions of the intended development. So usually you give this spec document to an engineer, and he or she looks at it, gets the understanding of what the entire requirement is in detail, gets to see all the API contracts, for example, API contracts or the pipeline required to be built. Okay, and some other information which is required for implementing this particular requirement. So this is what a spec document is, and by following this the development is being done. So that's why it's known as spec driven development. Now when we come to the coding agents, what people usually do is that they give a prompt, then the coding agent spits out code. Okay, then somewhere here there is an error if you happen to run it. If you don't run it, you never get a chance to see the error. If you run it, you can get an error. What you do is that you paste this inside this coding agent, which again becomes the context, and the coding engine again spits out the code, and this loop goes on and on. By the time you are working for around half an hour or more than an hour, there is a context overflow. That is, the context becomes too huge for the LLM which is powering your coding agent, and then it starts getting confused, and it again spits out the uh, code which is less optimal. So instead, what we can do is that we can use the spec-driven development to instruct the coding agent. But the way people use spec-driven development is again, most of the times it's an overkill, because they give a spec.md file. We will come to it later. What this means is that, and they instruct the coding agent to spit out the code, then it gives an error, you paste the error all over again, so and so forth goes. Some people even go overboard, they create a new spec out of the error. This again goes in on loop. So I would say that if you get an error, just paste the error and get the job done. And use the spec-driven development only during the initial phases of any enhancement or a new development. But for trivial matters like changing a line of code or anything, you can just prompt it, right? So that's the first thing. The second thing is that the spec-driven development file, okay, first of all, it should always be inside a directory, and this directory should be referred in agents.md file, okay, which is a file to instruct your coding agent. We will cover this next, but this spec driven development or specs folder, if you want to call it that way, should be mentioned inside your referred inside your md file, so that your coding agents looks into the specs file. So what I usually do is that I have a specs folder. So I have a specs folder, and inside this I like to arrange all my specs files. So these are all markdown files, and it has all the requirements So let me first tell you what the spec file would usually look like. So the spec file, what I usually do is that I put the title, which is for the LLM to read. It becomes clear what the spec file is all about. Then the requirement in detail, then anything which is required for the implementation of this requirement, which can be like the API contracts, or what else, this can be the what pipeline needs to be built, for example. So basically all the things that is required to make this requirement a reality. Okay, all these things comes under the spec file. And so this spec folder I would like to refer inside the agents.md file and instruct my coding agent to always look into the latest spec as per the timestamp, because again these are all file systems, right? So the agents can look into the timestamp, and whichever is the latest spec, they usually pick that up and do the stuff. One more thing that I like to do inside my spec.md file is that I put in tasks. I divide this entire requirement into different tasks, like task 1, task 2. So this is in line with what we usually do in real life. So if you are working on a requirement, you don't take the huge chunk of task and do it. You try to split that into different subtasks so that it becomes easier for you to work with. Then there is another term known as skills. So these are again empty files, and I like to put them inside the skills directory. And again, I would like to have it mentioned in the agents.md file. So what usually happens is that whenever the coding agent starts um, starts for the first time, or starts the implementation first time, it picks up the it looks into the skills folder, okay, and it reads through all the files, all the skills files, and tries to pick the metadata, or the front matter of the skill file, which is usually the title and the ability of the skills. So what it does is that these are very few tokens, first of all, and this tells the coding agent that you have access to all the skills and pick it up whenever it's required. So in this way we don't inject the entire content of these files into the coding agent, which saves you the token, and also it keeps the coding agent's context as light as possible. What I usually do is that inside my skills folder I do have a registry.json, and this registry.json looks something like this, that I have the skill name mentioned, okay, and the ability of the skills, or the capability the skill imparts um, to my coding agent. And I usually have this referred inside my agents.md, so that um, the coding agent reads this JSON files and instantly it is aware of what skill it has access to and the ability of those skills. This is again another way to keep things organized and to reduce the token usage rate. Now a skills.md file usually has a title, okay, which is super important to make the LLM aware of what the skill is all about. Then I put in a header like what it is about. So I briefly mention what the skill does, and then the instructions. These instructions can be as simple as um, you know something written, some instructions written in English, or it can have reference to other scripts. Okay, so it can have reference to other scripts. Now inside my skills directory I have the MD files, and I also have a script subfolder. So these script subfolders are simple Python files which have certain reusable script. Okay, so it has reusable scripts which the coding agent can use whenever required, and there are also certain scripts which the coding agent creates repeatedly over and over again for different tasks. So inside the agents.md file I instruct it to store the scripts which it thinks that it can um, reuse, and I mention and I mentioned the coding agent to keep the scripts inside the script subfolder. So this way all my skill files are inside the skill folder, and the reusable scripts are also inside the skill folder, and the scripts which I create, I like to refer that back into the skills file, so that whenever a skill is there which does require the coding agent to use certain script, it uses that. Okay, so this is the way I like to organize, or create my coding workspace and utilize the coding agent to the fullest without overflowing the context or without burning through lots of tokens. Now we'll move to the VS Code environment and show you exactly how I organize these things, and a small project which I developed to make my life easier with the coding agents.
So this is the project which I have been working on, and it works on the same principle of skills and spec-driven development using the anti-gravity coding agent. You can use any other coding agent for this, and so the coding agent does not matter. The principles and concepts matter. Uh, So this is to demonstrate that how to make the better use of coding agents, and it is an implementation of the concepts that I have shown on the whiteboard. So to quickly go through the uh, architecture of my project. So at the top level, I have a detector code. What it does is that um, it also has a companion CLA application. So what it does is that it scans the file in a given directory and then checks if it is in landscape mode or portrait mode, and then divides it as per that. And it also works across videos and images. So if your um, workspace, or if your project has both videos and images, then it also segregates that as per that, and also segregates them with if they are landscape or portrait orientation. So those will be there in their own subfolders. And the way it achieves that particular thing is I have a local VLM running. So the VLM that I am using is Montream. It is a tiny model, but works very well for this use case. And then I use the payload library. So what this does is that in the images and video files which have the proper um, exif data, uh, it can detect the it can extract the orientation out of that, and also the file extension. So whichever images or videos have proper exif data, the orientation would be extracted from that, and whichever don't have the proper exif data, or the exif data cannot be um, used to determine the orientation, then the local VLM would be used for that. So this does not put too much pressure on the local VLM, and this makes this whole process very quick. And also for most of the cases I use OpenCV for reading their properties, and this is another way which with which it inspects the video and determines the orientation as well. And there are also raw files over here, and for that the raw py package is used, so it is helpful in reading the raw images and their details. So the way it does, the way it does is that an API call is made to Ollama, and then this detector itself uses the payload to read the exif files, and also uses OpenCV library for reading the you know video frames and their different properties. And this file just determines, lists down what goes on behind the scenes. I am not going to deep dive into it. Okay, I will put a link to my GitHub repository. You can go ahead, fork it, look into it, and then um, deep dive into it and modify it as per your convenience. But the whole point of showing this project is that what I've done is that I have given um, certain skills for my agent inside a skills folder. So this is my project structure. This is the virtual environment that I am using, and this is the skill folder, and this is the spec folder. Inside the skill folder, I have put a plan skill. So as I mentioned earlier that I have some basic formatting for my skills. So here I say what it is all about. Uh, so what this document is all about, or what this skill is. Okay, so the coding agent can go through this document, understand what the skill is, and then work as per that. So whenever I launch my coding agent and say that hey, let us plan something, then it searches for the plan skill in the workspace and then gets going. um, then once once the plan is done, I instruct the or prompt the coding agent to put all of this in form of a specification document. Okay, uh, so this is one such specification document, orientation detector spec, that's what I call it. And this entire spec sheet has been generated by my coding agent itself, and I had reviewed it, okay, just to make sure that it hasn't done anything wrong. So the whole idea is that even the skills and the specification document should be made by the coding agent, and you should come in as the reviewer just to make sure that everything is written as is. So as you can see, the specification documentation has the title of the specification document, the objective, what this is all about, and the context and what is required, what is the requirement. So for example, I want the artifacts to be divided into images and videos folder, and there should be subfolders like as per the orientation. So I have two orientations, so I prefer to use two. And how the project should be set up, basically here I am instructing that what mandatory items I should be having, and what initial mandatory dependencies should be there, um, how the specification of where it should be stored. Okay, uh, then what kind of integration I need to do. For example, here I am using Ollama for hosting my local model, and I basically give it what the constraint is, what model I want to use, uh, in specific prompt to the VLM. So I am defining even these things, and these are important because I am also instructing the coding agent that hey, you have the integration items ready, go ahead and set up my environment. Okay, then how the media files should be processed, and I have set up logic. So see, the whole point is of doing this is not to let the coding agent run wild, but to instruct it step by step and to the point what about what you want. And then comes the organization logic. Basically, I want here is the project structure or the output folder structure. uh, I also want to have it like a CLI, and this agent to be set up as a CLI. So I also mentioned what the CLI should be having, what argument it should be um, accepting. Okay, and then of course, since we don't want the agent to just spit out code and be content with it, I also instruct in the spec itself how to verify the entire code. So this is very important because most of the times we instruct the coding agent to code something for us and we are happy with it. But I would say that inside each of your spec, do place the ways in which your coding agent can verify and test. So here I've mentioned like there should be unit test, there should be integration test, and there should be end-to-end test. Okay, and since this was a um, and I have not only instructed it to create test, but I have also instructed it to test it fully. Okay, run all the tests. So what happens is that this is kind of a loop for the coding agent. So most of the time you might be hearing this loop is more than enough for creating a agent, right? uh, so this is the part of the loop. I mean, it's not entirely true that only a having a loop um, would make your agent very good, but you should have the specification and you should have a way for the um, way for getting some kind of feedback into the coding agent, so that it can self improve. And the way to do is that we need to make sure that it creates proper test and runs them. Okay, and after this is done, I ask my agent to look at the spec file and start implementing. Okay, and there is one additional thing, Gemini.md. Since I am using anti-gravity CLI, so this is the file for instruction. Okay, so this can be an agents.md file or any other file that you want to be at your project root, which could be the super instruction for your agent. So here I have very simple instructions like always use the plan skill and never implement anything before planning. You can have other instructions which um, you want your agent to follow. Okay, and you don't want to type in the instructions over and over again. Okay, always. So my coding agent gets to work and created this entirety of the project. It installed whatever dependency was required, and it also created this dependency file, installed everything, implemented all these things, and tested it. If the test passed, it kept the code. If the test didn't pass, it didn't. It just tried to modify the code. Uh, I and in all my project, I also instruct the agent to analyze the project and design a or create a design document. It is very helpful because um, if a third person looks into this file, they can go through the diagram and instantly understand what the project is all about. So it is very important to have a design document so that there is no slop in understanding the uh, design of your project. Okay, and this is also something that you can instruct the agent to do. And in fact, I also ask the agent to write a design specification document for me. Okay, and over there I mentioned that what kind of design document I would want. So that's it. That's how I arrange my project. And when I would run this video organizer, then I would show you. how my images are arranged. So these are see we have I have the images and videos folder. Earlier these folders didn't exist, and and I and you can see that there are subfolders named after the orientations, and all the images are oriented as per their inside this these are portrait images. Okay, and there are certain more images which are landscape images. Okay, and the same thing goes on for videos even. Okay, so as you can see, these are all portrait videos. Similarly, these are all landscape videos. Okay, and yeah, so you know this makes life easier. There were over 4,000 images and videos, okay, from my recent travel with my family, and if I wanted to sort them by hand, I could, but it would take time. So I used an agent, coding agent, to create a very simple agent for me, which can rearrange this stuff for